Besides the halogenation, we can also perform nitration of benzene. And during the nitration, benzene will be converted into nitrobenzene when we have a mixture of concentrated nitric acid and concentrated sulfuric acid. The nitration of benzene follows the general reaction mechanism of an electrophilic substitution reaction, but before we now need two initial steps. And in those initial steps, both nitric acid and sulfuric acid react to form an electrophile, which is now called nitronium ion. Let's have a look on these two initial reaction steps. So we start with sulfuric acid and nitric acid. Sulfuric acid is a stronger acid compared to nitric acid. That means sulfuric acid will donate a proton to nitric acid. And this type of reaction is called acid-base reaction. So we can say the first initial step is then the acid-base reaction between sulfuric acid and nitric acid, and hereby the nitric acid gets one proton from the sulfuric acid, and then we end up with these molecules, and here you can see that the nitric acid contains now a protonated hydroxide group. And the protonated hydroxide group is a very good leaving group, and hence, as you can see here, the second step is then the formation of water, which is a good leaving group, and nitronium ion. And nitronium ion has the molecular formula NO2+, so it is a cation and constitutes a very strong electrophile. After these two initial reaction steps, we then go into the third reaction step where benzene reacts as nucleophile and donates a pair of electrons to the nitronium ion. And during the third reaction step, the non-aromatic carbocation intermediate is formed. And in this third reaction step, it is very important to see that we have now a shift of electrons. And the reason for this is that if the electrons would not shift, we would end up with a nitrogen atom that has 5 bonds, and this is not possible. So how do the electrons shift? You can see it here. At the same time, when the two electrons from the benzene form the new carbon-nitrogen bond, a pair of pi electrons in one of these nitrogen-oxygen double bonds moves onto one oxygen atom, so that the nitrogen then does not end with 5 bonds. And again, this intermediate non-aromatic carbocation has 3 resonance forms. Then in the fourth, last and fast step, we have a deprotonation of the carbocation in order to form the nitrobenzene molecule and the hydronium ion. And this deprotonation step is a very fast step because the driving force of this step is the regeneration of the aromaticity. And if you have a look on this nitrobenzene molecule, you can see it is not the only structure, so you could also imagine that the negative charge is not on the left side, but on the right side.